Good afternoon and welcome to today's webinar. I am delighted to have you all here with us today. We have an exciting and insightful webinar here featuring one of our engineer Mubarak as the speaker with us, who has been involved with this project for a while. Before we begin, I just want to mention that your participation and engagement are very important to us. If you have any questions during the webinar, please feel free to ask them in the Zoom chat. We'll address them during the Q&A part of the webinar. Without any further delay, let's dive into the program. Over to you, Mubarak. The floor is yours.
Thank you. Hello, everyone. I'm Mubarak, currently working as a software engineer at AppsCode. Today's webinar, we will see how we can seamlessly provision and manage Pgpool on Kubernetes using KubeDB. So without further ado, let's dive into the webinar. Okay, so let's first go to the table of contents quickly for today's webinar. So in this webinar, we'll discuss what is Pgpool. Also, we will briefly discuss about Pgpool architecture. We'll see how KubeDB provision Pgpool. Also, we'll see the offerings from KubeDB about the features and specifications of Pgpool. Also, shortly we will have a live demonstration of the webinar. Okay, and at last we'll have a Q&A session for you guys. If you have any specific question, we'll try to answer and discuss about it. Okay, so what is Pgpool? Pgpool is a versatile proxy solution positioned between Postgres servers and database clients. You can configure multiple Postgres server as a backend for Pgpool. Pgpool also offers essential functionalities such as connection pooling, load balancing, in-memory query caching, and many more. Also, you can route specific query to specific Postgres with pre-configured query rules. Pgpool effectively enhances the performance, scalability, and reliability of Postgres database system. Okay, now we will briefly discuss about Pgpool architecture. Here in these two pictures, we can see the architecture of Pgpool. Now let briefly discuss about it. For specific task, Pgpool have specific process. Initially, Pgpool had the main parent process. Then the parent process for three type of process. One is PCB process, and another one is worker process, and the last one is child process. The worker process will check replication delay for Postgres backend servers on behalf of Pgpool. Then if you use KubeDB Postgres, you may not need this worker process for replication check because KubeDB Postgres already have these functionalities. Also, we have a PCB process. With this PCB process, the Pgpool admin can remotely configure and control Pgpool. And the main process here is the child process. These child processes are these child processes are this child process will do the connection pooling and the connection handling and all the necessary steps. We can configure the child processes if the number of child processes can be configured in the Pgpool config. Also, we have connection pool here for each child process. Okay. Now let's see what can we do with KubeDB Pgpool. Here, when a user apply a Pgpool CR or custom resource, KubeDB provisioner will create a pet set, which is a custom resource made by AppsCode. And it is basically a replacement of stateful set, but can do more things than stateful set. Also, KubeDB provisioner will create necessary secrets, services, etc. Then if you use KubeDB Postgres, you just need to mention the appending KubeDB made for Postgres in the Pgpool CR. And then KubeDB will do the rest for you. But if you use an external Postgres, you need to mention the app binding and also create the app binding for Pgpool. Also, Pgpool has three type of termination policies. When the termination policy is wiped out, you can delete all the resources by terminating Pgpool. But if the termination policies do not terminate, the termination will be rejected. Also, if the termination policy is delayed, the secrets will be remained and the other resources will be terminated. Okay. So here the offerings from KubeDB for Pgpool. Pgpool will manage external dependencies such as Postgres management for you. If you use KubeDB Postgres, it will handle all the things necessary for a Postgres server. Also, we have customizable health check for Pgpool. Also, you can configure Pgpool with your own configuration easily with the same YAML of Pgpool. KubeDB Professional will sync users and password to Pgpool for all the user and that exists in the Pgpool backend server automatically for you. We also have multiple termination policies. We also have default security context where we can enforce Pgpool pods and containers to use non-root users, and also KubeDB Pgpool have capability to run in restricted namespace environment. So with this command, you can install Pgpool on your cluster. Also, the links will be given in the description for detailed info. So now let's dive into the live demo session. Okay. Uh, for the cluster, I'm using kind cluster here. I have already configured a KubeDB Postgres for you. You can also install it by KubeDB documentations. Also, here the sample YAMLs we are using for this webinar. Uh, let's discuss about the fields. Here we can specify the Pgpool version. We currently have two version, 4.5.0, which is the latest version for Pgpool. Also, we have 4.4.5. Here we can specify the replica numbers. Here in the Postgres ref, we need to mention the appending name of Postgres. Also, the namespace where the appending resides. Also, we can specify the termination policy. Also, if you need to use the sync user option, you can enable it. If you enable it, the KubeDB Professional will automatically bring the username and passwords from backend Postgres to Pgpool. Also, we can custom config the Pgpool with init config field. Here, you can specify your custom configuration. Okay. Here, we will apply the Pgpool YAML first. Let's see it. Here, at first, we'll deploy the sample YAML without the custom configuration. Here, we can see Pgpool will create a auth secret for you. This auth secret will be used for the PCP users, mainly the admin users for Pgpool. Also, the sample config. This configuration file will be created from the init config field or the default config provided by KubeDB. And we have on replica, so it is running, and also we can see the DB is ready for use. So we can put forward to the Pgpool service for using it. Also, here in this field, we can see we can specify the namespace for Postgres. So that means we can configure cross namespace Postgres for our Pgpool. Here our Pgpool in the pool namespace and the Postgres in the demo namespace. Okay, you can use the root password from Postgres. Here we can get it by this command. Here we get the password from the backend.secret from Postgres. From this one. We are using KubeDB Postgres for this demo. And we can also save it in the environment variable. So we do not need to refill it. Okay, now we can use the PSQL client for connecting with Postgres. Here we can also see the logs for Pgpool. Here we can also create a user. Let's create a user first. Here the zero backend means the primary Postgres and the one means the secondary Postgres. Also, you forgot to mention that uh, uh, for our KubeDB Postgres, we have two services. One is the main service, which will redirect the connections to any Postgres. But here is the standby service, which will redirect the queries or connections to only the secondary service, secondary ports. For Pgpool, we can configure any number of backend Postgres, but with the KubeDB Postgres, uh, we assume that there is two services. One is main service, and one is the secondary service. So we configure with that. You do not need to specify anything if you use the KubeDB Postgres. Okay, now let's do some query. First, we will create a table. Here we can see the write query hit the backend 0. Here the backend 0 is the primary Postgres. The write query will always be redirected to the primary Postgres. And the read queries will be load balanced throughout the primary and secondary servers. Uh, Now let's get a select query. Here we can see the secondary service was invoked from this query. Okay. Also, we can see we have uh, created an user. So Pgpool have a password file for its own authentication purpose. Uh, Here, uh, the password was created in backend Postgres. This user and password will be automatically fetched to Pgpool. You can see it by executing in the Pgpool port. Let's see it. Here is the default path for the full passwd file, where the all the passwords resides. Here we can see user Bob was registered automatically here. This is because of our sync user features. Now let's do a custom config with the init configuration fields. We will use this YAML for this purpose. Here we will also see the load balancing and also the collection cache options. Let's first delete the existing Pgpool. Here is the exact YAML we showed before. So let's apply it. We can see it is provisioning. We can see this is in running state. We can also verify the configuration by executing in the Pgpool port. Let's do it. Here we can see the custom config applied. We also have default configuration. If an user do not give any field value, the values will be automatically filled by our provisioner. Here we can see the number of init children is 5 and max pool is 50. We just applied our custom config to achieve that. Also, I do not need to worry about all the fields because KubeDB will handle some fields for you. Okay. And now let's see the load balancing and query caching. Now let's see the log. Okay. Uh, okay, these queries are running in background for health checking, so you do not need to worry about this. We can also use the Bob user. Now list the user Bob. Use the user Bob. First, export the password. So we are connected as user Bob in the Postgres database. Now let's do some value insertion in our previously created table. Where we can use the command. Here we can see the it was in the uh, main Postgres server. Also, it again hit the main Postgres server, the primary server. Write query will always be redirected to the primary Postgres server. Now let's do some read query. Here we can see the secondary server was heated. Here we can see the primary server was heated. Again, we can see the primary server was heated again. Again, the primary server was heated. The secondary server was heated now. This is because of our load balancing. Here we said we want load balancing mode 1. Here also we specified that we want statement level load balancing. Statement level load balancing means for each query there will be load balancing occurred. But if you use session level load balancing, then session level load balancing will be configured as when the user first connect to the server. A user will be connected to a backend server, and the query will be redirected to the this server every time. There will be no load balancing after that. But if you use statement level load balancing, the query will be balanced every time. Now let's delete it. We will also see another feature for Pgpool, which is query caching. Here it is not enabled. We can enable it by this. Let's see this. Here we just added an extra field. The field is memory cache enabled. If we use this field, the query caching will be automatically enabled. Now let's apply this YAML. So let's see the log. Now let's again get connected to the Postgres server. You can see our Pgpool is in a ready state. Okay, now forgot to port forward. Let's do port forward. Now again run the query. Here you can see now the query was fetched from the log, from cache. If this query cache feature is on, Pgpool will try to use the query cache feature. Uh, if there is a previous result from any select query, Pgpool will try to use it. We can also see the query cache information by this command. Okay, let's first expand the display. Here we can see 61 queries was hitted in the cache. This many query because we have the health checker running in behind. Also, we can see the 20 queries was missed from the cache. We can also see the cache hit ratio. 75% of the query was fetched from the cache. There are many configuration parameter for Pgpool. You can use all of this. We have shown you the main features. There are also multiple small features which you can use. So about the future plans. In future, we will bring Pgpool monitoring. In case we have already have the monitoring feature here in our latest release. We will show this in the future webinar, but it is already here. The monitoring feature, the Prometheus and Grafana dashboards, all are here. You can check it. We can keep the links in the descriptions. Also, we will in future soon we will enable TLS for our Pgpool. Also, we will bring ops request so that you can reconfigure your Pgpool in running state. Okay, so if you have any question, we can answer and discuss about it. So, do you guys have any questions? Okay, I think we don't have any questions. So, thank you for joining. See you soon. Okay, bye.
So this concludes our today's webinar. Thank you all for your participation. Hope to see you again next time. Our webinars are actively scheduled on our website. Visit appscode.com/webinar to register. Have a good day.